How does nuclear fusion power the stars? Imagine a giant ball of glowing gas shining brightly in the night sky. Have you ever wondered what keeps it burning for billions of years? The secret lies deep inside its core, where an incredible process takes place. Stars produce energy through something called nuclear fusion, which happens in their super-hot centers. Nuclear fusion is when tiny atomic nuclei combine to form heavier nuclei, releasing a huge burst of energy. In stars like our Sun, the main process is known as the proton-proton chain. Here's how it works in simple terms. It all starts with hydrogen nuclei, which are just protons. Under extreme heat and pressure, two protons fuse together to create a new particle called deuterium, which is one proton and one neutron. When this happens, a positron, the antimatter version of an electron, and a neutrino are released. Next, the deuterium nucleus fuses with another proton to make helium-3, which has two protons and one neutron. This step releases gamma rays, which are high-energy light particles. When two helium-3 nuclei collide, they form helium-4, which has two protons and two neutrons, and they send two protons back into the process. Overall, for hydrogen nuclei turn into one helium for nucleus, and the tiny difference in mass between the original hydrogen and the helium gets converted into energy based on Einstein's famous equation, E = mc². This energy escapes the star as light and heat, which is why stars glow. To make this happen, stars need to reach temperatures of about 10 million Kelvin or more, which is incredibly hot. This heat is what allows protons to overcome their natural repulsion, or electric charge, and fuse together. The energy produced pushes outward, balancing the inward pull of gravity, keeping the star stable. Larger stars use a different fusion process called the carbon-nitrogen-oxygen cycle, which uses those elements as catalysts to fuse hydrogen into helium, but it needs even higher temperatures, around 15 million Kelvin. As stars grow older and their cores get hotter, they can fuse heavier elements like carbon and oxygen, creating many of the elements we find in the universe. The energy from nuclear fusion in stars is what makes sunlight and warmth possible on Earth. It powers weather, climate, and helps plants grow through photosynthesis. Scientists are also working on controlled nuclear fusion here on Earth, hoping it could become a clean energy source someday. So, in simple words, stars shine because of nuclear fusion, where hydrogen nuclei fuse into helium, releasing energy that keeps the star bright and stable. This process is the reason stars live, die, and create the elements that make up everything around us.